Welcome back. I've read a little of my work on problem 3, and it seems very clear that I'm under stress, so my thinking is clouded. I guess you realized that 1 plus x times 1 minus x actually solves the problem, and I discarded that while working on the problem. So it's clouded thinking, and that's common when one is under stress. That's just a fact we have to accept. Today we are going to work on creating a program, and then I solved problem 2 a little better, so we'll go back to that as well. But let's start on the problem as it's stated. So we have to show that the number of solutions here, they may be odd or even. So one equation is n equals 2x squared plus y squared plus 8z squared. And the other equation the idea must be to take a factor. That was too much. 2z squared, that gives 4z, so that's 8. So if we have a solution to this equation, then we get a solution with even z to this equation. Now you can clear or see. So if you have a solution to this equation, we get an even solution to this equation. And if we have an even solution to this equation, then we can just put 2z in here, and then we get a solution to this. So I believe that A is clear. So the next problem is to write a computer program to test condition B in Tunnel's theorem. So I needed to work a little on Maple again, and I found some interesting procedures we can use. There is I square free, which does something. I can't really formulate it clearly, but I factors that makes factorization exactly in the form we needed. So now we can take the square free part of an integer by factoring it and only looking at this part, and then take modular 2 of each of these factors and compute it. So that's easy, and I just made a test. And then we have the program for Pythagorean triples and the congruent numbers that we get. So here it is 6, 21, 5, 14, etc. The same ones we saw, but now we have a good procedure solving it. And then I wanted to check if we could find something like 12. That's very silly, really, because 12 isn't square free. But 7 is a congruent number, so can we find one satisfying that? And yes, we can. Actually, we only need to go up to 15. So 7 is a congruent number, and that's the triangle, the sides, that gives that. So that's very satisfactory. Now back to tunnel. I first used it the proposition on page, or the theorem on page 3, I used that for even n as well, and found out that 6 wasn't a congruent number. Not very good. Then I read the theorem again and noticed that n had to be odd. Damn it. Well, it's very simple. The one giving the strongest condition is 8z. So we start by finding out what it can be at most. So we divide n by 8 into division, and then we take the integer square root, and that gives a bound for z. And then we let z go from minus to plus. I find that easier than just going from 0 to zm and then finding out how to count it. That was a little complicated for me. And then the remainder, which can be taken up by 2x squared. So we find out what the maximum x value is. And the remainder, that may be a square. If it is, then we have a solution to the equation. And then we have to find out whether it's odd or even and count whether the number of odds and the number of even. There is a little question here, because when it's a square, then if it's 0, there's only one solution. And if it's non-zero, then we have two solutions. So we have to add 2. So that's a way of doing it. And then we just, the result is whether the number of even solutions equals the number of odd solutions. So that was, I was fortunate that that took very little debugging. So we can just get the numbers. Now, 9 makes no sense at all because it's not square free. That is reduced to whether 1, so that is wrong. Here's another square free. Actually, 5 is, 1 isn't, so 25 is neither. And 27 isn't square free, so it only holds when it's square free. But it turns out to be the right result anyway. All right. Then I went to page 221 and found the condition when n is even. And it was pretty easy to correct the procedure so it handled that as well. And then I can just from 1 to 20 print whether or not. We find, of course, 4 is true. It has solutions, and they are all z is, of course, 0 in all of them. So there are 4 solutions with z being even and 0 solutions with z being odd. But that doesn't make sense because it's not square free. True, 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 false, 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 true, 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 12. Again, it's false because 3 is false. But apart from that, we've solved the problem. So guys, that was it for today.